It's kind of funny. Some debates, they feel so settled, like so firmly in the past, you'd never think you'd need to revisit them.
Yeah, absolutely.
And yet, the shape of the Earth. Well, it turns out for some people that conversation is very much still alive.
It really is.
You sent us this fascinating stack of information. You just called it pasted text, and it really goes deep on this. So that's our mission today. A deep dive into the flat Earth versus the global Earth perspectives.
Okay.
We're going to try and unpack the core arguments, maybe trace the origins of these ideas a bit, and figure out who believes what today.
Sounds like a plan. Trying to get informed without falling completely down the rabbit hole, maybe.
Exactly. Okay, so where do we start? The established science.
Yeah, let's start there. It's kind of remarkable because for most of us, the Earth being, round, spherical, it's just a given. It underpins so much science.
Right.
The consensus is just overwhelming. The Earth is an oblate spheroid. Think of, like, a basketball that someone's gently squashed top and bottom because it's spinning.
Gotcha. Slightly wider at the equator.
Exactly.
And the evidence for that is, well, it's kind of everywhere, isn't it?
It really is.
I mean, just thinking about gravity first.
Yeah.
The text you sent points out something pretty simple but powerful.
Hmm.
On a flat disk, gravity would pull everything towards the center of the disk, sideways for people near the edge.
Right. Not straight down like we experience.
Exactly. We wouldn't have this consistent downforce no matter where we are. It wouldn't work like that.
Precisely. That consistent downward pull everywhere, it's a really strong indicator. It points towards a spherical mass pulling towards its center.
Simple but powerful.
Yeah. And then you've just got the sheer volume of visual evidence, pictures.
Oh, yeah, the pictures from space.
Decades of them.
Yeah.
Photographs, videos from countless space missions, NASA, sure, but also the European Space Agency, Roscosmos in Russia, many others.
All showing
A spherical Earth. It's pretty hard to argue with those images when you see them piling up from so many different sources.
Okay, so photos from space, gravity. What else is sort of a classic proof? Oh, lunar eclipses.
Ah, yes. That's a great one. Observable from, your own backyard sometimes.
It's so simple but effective, right? The Earth goes between the sun and the moon, casts a shadow.
And that shadow on the moon.
It's always round, always got that curve.
Always. A flat disk, depending on how it was angled towards the sun, it would sometimes cast maybe an oval shadow. Or even just the line, potentially.
Right. But we only ever see that curved edge.
Never fails. It's a classic piece of evidence for a reason. Easy to see.
Okay, so connecting that to maybe the bigger picture, how we actually navigate the world. You sent info on airline routes, shipping routes.
Yes, that's another really practical piece. The most efficient way to travel long distances isn't a straight line on your typical flat map.
Right, they look curved on those maps.
They do. They're called Great Circle routes. Basically, the shortest path between 2 points on the surface of a sphere.
And these routes make perfect sense only if the Earth is a globe.
Absolutely.
Yeah.
And the fact that airlines, actually use these routes every single day, it's not just theory. It saves them time, saves them fuel. It's real-world confirmation.
Yeah, I remember seeing that example, like a flight from, say, South America to Australia. On a flat map, it looks like it should just go straight across the Pacific.
Seems logical on a flat map.
But on a globe, the shortest path actually curves way down south towards Antarctica almost.
And that's how they fly it.
Exactly how they fly.
Okay.
And then there's the Coriolis effect. This one is a bit more complex, I think.
It is a bit more abstract, yeah. But it has very real effects. It's a direct result of being on a rotating sphere.
It affects weather patterns.
Big time.
Yeah.
Weather systems, hurricanes spinning different ways in different hemispheres, ocean currents. The way these large-scale systems move is influenced by it.
So the fact that weather behaves like it does
is strong evidence for a rotating globe.
Yeah.
Okay. So we've laid out some pretty solid scientific ground for a global Earth. Gravity, photos, eclipses, navigation, Coriolis effect.
A lot of converging evidence.
Right. So now let's switch gears. Let's try and understand the flat Earth's perspective. What are the core beliefs there? And the texts you sent mentioned there are variations, right?
Yeah, definitely variations. But some common themes emerge. The basic model is usually a flat disk.
With the North Pole smack dab in the center.
And Antarctica isn't a continent at the bottom.
No, it's an ice wall around the edge.
An ice wall ringing the entire edge of the disk, yeah.
Okay. And what about the sun and moon in this model?
They aren't these huge, distant objects like in our standard model. They're much smaller, much closer, and they circle above the flat disk, like spotlights almost.
Interesting. And gravity, how does that work?
Well, standard gravity, the idea of mass attracting mass towards a center,
Hmm.
that's often rejected.
So what's the alternative? Often, explanations involve things like density and buoyancy. Things float or sink based on how dense they are compared to the medium they're in, like air or water. That's used to explain why things fall down.
Or sometimes isn't there an idea that the disk itself is accelerating upwards, creating a feeling of gravity?
That's another explanation sometimes proposed, yes. Constant upward acceleration.
Wow. Okay. And space travel, satellites, all those photos we just talked about.
According to this perspective,
Yeah.
largely fate. Part of a massive conspiracy.
A conspiracy involving...
Essentially, NASA is central, but also various governments, maybe other space agencies. The idea is a huge, coordinated deception.
That's quite a scale. The text you sent, did it touch on why? Like, what's the supposed motive for faking around Earth?
It seems to often stem from a really deep skepticism towards authority in general. A belief that the public is being deliberately misled, maybe for control, maybe for financial reasons, maybe tied into hiding religious truths. The specific why can vary a lot among believers.
Okay, so if they reject the standard evidence, what arguments or proofs do they put forward for a flat Earth? The horizon one seems common.
That's probably the most cited one, yeah. You look out over the sea, over flat land, it looks flat.
And the argument is, if it's a sphere, we should see a curve.
Exactly. But this really ignores, well, two things. Perspective and just the immense scale of the Earth.
It's just too big to see the curve easily over short distances.
Precisely. The curvature is incredibly subtle over, say, a few miles. Your eyes just can't pick it up without specific tools or looking over vast distances.
Right. Okay, then another one is, water always finds its level. How does that supposedly prove flatness?
The idea is that if water always stays level, how can oceans curve around a ball?
But that's a misunderstanding of gravity, isn't it?
It is. Water does find a level surface, but level just means perpendicular to the force of gravity.
And on a sphere, the direction of down, the pull of gravity changes depending on where you are. So the level surface of the water follows that curve.
Exactly. The surface of a large body of water conforms to the planet's gravitational field, which means it curves.
So how do they explain that consistent downforce then, if not gravity as we know it? Does the text elaborate beyond density or acceleration?
Those are the main ones mentioned in the text. Density buoyancy, or the upward acceleration idea. It avoids the need for a central gravitational pull.
Got it. And then there were those claims about flights, southern hemisphere flights specifically.
Right. The argument some make is that flight times or routes between places like Australia, South America, South Africa, they don't make sense on a globe map. They seem too long or indirect.
But the text you sent said these claims are usually based on, well, on flat Earth maps themselves.
Exactly. They often use distorted projections when making these claims. When you plot those same flight paths on an actual globe, using the real Great Circle routes we talked about earlier,
They make perfect sense.
they make perfect sense. They are the shortest, most efficient paths. The supposed discrepancies disappear when you use the correct model.
Okay. And underlying a lot of this, you mentioned the conspiracy angle, the distrust of NASA governments.
Yes, that skepticism seems pretty central. It fuels the belief that evidence for a globe is fabricated or part of this grand deception.
It's really interesting to look back, though, because this isn't the original human belief, is it? I mean, ancient cultures, yes, some had flat Earth ideas. The text mentioned Babylonians, Norse, early Egyptians.
True, many early cosmologies were flat, but the idea of a spherical Earth is also ancient. It wasn't, invented by NASA.
Right, like Eratosthenes, the Greek philosopher, back in the 3rd century BCE.
Yeah, it's amazing. He calculated the Earth's circumference with surprising accuracy just by observing shadows in different cities on the same day.
Incredible. And the text says that by the Middle Ages, most educated people accepted the Earth was round.
It was pretty much the standard understanding in learned circles across Europe and the Islamic world by then. The flat Earth belief in the Middle Ages is largely a myth popularized later on.
So how did we get this modern resurgence? The text points to a guy named Samuel Rowbotham in the 1800s.
Yes, his book, Zetetic Astronomy. That seems to be a key starting point for the modern movement.
What was his basis?
It was apparently based on a very literal interpretation of the Bible, combined with some, let's say, flawed experiments, like the Bedford level experiment, which supposedly showed no curvature over a long canal.
Ah, the Bedford level experiment, I've heard of that. It's often cited.
It is, but it's also been thoroughly debunked. He didn't account for atmospheric refraction, how light bends over distance.
Okay. So Robotham planted the seed. Then what?
Well, the idea kind of simmered on the fringes. Then, in the 1950s, Samuel Shenton founded the actual Flat Earth Society in the UK.
Keeping the flame alive, so to speak.
Pretty much. It remained a very small niche group for decades.
Until the internet.
Bingo. The internet, and especially social media in the last, say, 10, 15 years, that seems to be the major catalyst for the revival we see now.
YouTube, TikTok, Reddit, places like that.
Exactly. These platforms provide spaces where believers can find each other, share evidence, reinforce their beliefs, and recruit new people.
It creates a community, an echo chamber, maybe.
Absolutely. The internet doesn't just let them share ideas, it really helps build these strong in-groups where alternative views are easily dismissed. That's a key factor in how these beliefs persist.
Yeah, that makes sense. These platforms can really amplify things, can't they?
They certainly can. Dissenting views might get blocked or shouted down within those specific online communities.
So who are the people holding these beliefs today? The text you sent suggests it's still, relatively small numbers overall, but they're quite vocal, especially online.
That seems right. Demographically, the text mentions links with certain strands of religious fundamentalism, particularly literalist interpretations of Christian or Islamic texts.
And also, you said overlap with broader conspiracy theory communities, people skeptical of authority in general.
Yes, there's a strong correlation there. It's often part of a larger worldview that questions mainstream science, government narratives, things like that.
And geographically, are there hotspots?
The text mentioned a few places with notably active communities. The US, the UK, also Nigeria, Brazil, and some parts of the Middle East were named.
But it's really crucial to stress, isn't it, that this is still very much a fringe view?
Absolutely critical. As the text points out, no country, no major scientific body, no significant scientifically literate population anywhere officially endorses a flat Earth model.
Even in those areas with the active communities, they represent a tiny fraction of the population.
A tiny fraction.
Yeah.
And while flat earthers often talk about doing their own research or experiments,
Like the Bedford level one.
right, which as we said was flawed and misinterpreted. When independent scientists or even amateur groups conduct careful experiments, the evidence for curvature is consistent.
The text mentioned other experiments too. Laser tests.
Yes. Laser tests over long distances showing the beam disappearing below the horizon due to curvature. High-altitude balloon footage clearly showing the curve.
Oh yeah, you see those videos online.
And even just tracking publicly available flight data, which aligns perfectly with the globe model and those great circle routes.
Not to mention, coming back to it, the constant stream of data and images from space. Not just NASA anymore.
No, ESA in Europe, CNSA in China, private companies like SpaceX launching satellites constantly.
All sending back data, images, enabling GPS, all predicated on a global geometry.
The sheer diversity of independent sources confirming the globe shape is staggering. From amateur scientists with lasers to multiple international space agencies, the idea that they're all coordinating in some massive centuries-long deception becomes, well, incredibly implausible.
Yeah, the coordination required would be unbelievable. It really makes you wonder about the psychology then. Why hold on to this belief so strongly against such overwhelming evidence?
That's a complex question, and the text touches on some possibilities. It suggests it might be less about genuinely engaging with the scientific evidence.
And more about other factors.
Possibly. Things like that deep distrust of authority we talked about. A desire for maybe a more special or alternative narrative about the world.
And the community aspect. Belonging to a group that sees itself as having uncovered a hidden truth.
That sense of community and shared identity seems really important. Being part of a group that's in the know, standing against perceived deception. There might also be cognitive biases at play, like maybe confirmation bias, or even the Dunning-Kruger effect, where people might overestimate their understanding of complex physics.
Interesting. It's like the belief serves a social or psychological need, perhaps more than an explanatory one.
That's a good way to put it. In a world that can feel complicated and maybe untrustworthy to some, these kinds of simplified alternative narratives can be appealing, especially if they come with a strong sense of community.
Okay, so let's try to sum this up a bit. On one side, we have this vast, interlocking body of scientific evidence gathered over centuries through observation, experiment, navigation, and now direct space exploration, all pointing unequivocally to a global Earth, specifically an oblate spheroid.
Yes, a robust scientific consensus built on verifiable data from countless independent sources.
And on the other side, we have the flat Earth perspective. It has some ancient roots, but its modern form seems largely revived in the 19th century and significantly boosted by the internet and social media recently.
Right. And it seems often driven by that skepticism of institutions, literal interpretations of certain texts, and a desire for alternative explanations, often involving complex conspiracy theories.
And it's crucial to reiterate, as the text does, that when you rigorously examine the claims made by flat earthers using basic physics, geometry, observable facts,
They just don't hold up. The proposed models are inconsistent with reality. There's a fundamental difference between a scientific theory supported by mountains of evidence and a belief system that often relies on misinterpretations, flawed experiments, and appeals to conspiracy.
okay. Well, we've definitely taken a deep dive into this surprisingly persistent debate.
Yeah.
We've looked at the solid science behind our spherical Earth and explored the core beliefs, the history, and the modern landscape of the flat Earth view.
It's been illuminating to map out the different kinds of arguments and evidence presented on both sides.
Yeah, and touching on the potential psychology behind it all is fascinating too. So maybe the final thought to leave everyone with, building on what you said. In this age of information overload, where we're bombarded with data, opinions, sometimes conflicting stuff, what are the deeper reasons why ideas that have been scientifically disproven for centuries can not only persist, but actually gain new traction and build these really passionate communities?
That's the million-dollar question, isn't it?
It really makes you think, doesn't it, about how we decide what's true, the nature of belief itself, and just how important critical thinking is in navigating the world today. Something to definitely mull over.